Today we will elaborate how to solve a trigonometric equation with TI 8384 in the radian mode. Let's say that we are given such an equation. 2 sine x plus cosine 2x equals 2 sine squared x minus 1. And we are given that x is between 0 and 2 pi. We would like to find the possible values of x. First of all, what we have to notice is that we are in the radian mode. And secondly, we have to specify the window x min and x max values as 0 and 2 pi respectively. The third thing that we have to note is, while entering sine square x, we have to use parenthesis sine x squared. That is important because sine square x is not written as it is in the TI-83 calculators. So, let's go back to our calculator and sketch our graph. 2 sine x plus cosine 2x minus 2 times parenthesis sine x close the parenthesis, take the square, plus 1. We will change our mode to the radian if it's not already in the radian mode. And we will set the window values x min to 0, x max to 2 pi, and x scale to 1. In this particular problem, we are not interested in what is here, what is there in this crest. But if we were, then what we would do is we would go to zoom and select zoom fit. Zoom fit does not change the x values. It scales the y values so that the graph fits the entire screen. Apparently, we have 3 zeros. One here, the second one here, and the third one here. In order to find the first one, we will be using the calculate minimum because the function appears to be tangent to the x-axis. Calculate minimum. We will specify the left and right bounds. 1 is a good choice for the left bound, and 2 is a good choice for the right bound. Okay, we see that the y value here is 1.12 times 10 to the minus 11. Well, this is actually a very minor calculation error. Such values, such small values, can be interpreted as 0. So, our first x-intercept is 1.57. And twice 1.57 makes 3.14, which is nothing but pi. So our first 0 is pi over 2. We will find the second And third, x-intercepts using calculate 0. The second 0 is 3.67. And the third one, it is between 5 and 6, so the left bound is 5, the right bound is 6, and our third 0 is 5.76. Going back to our original question, we have found 3 x-intercepts. One in here, second one in here, and the third one in here. And the zeros are 1.57, 3.67, and 5.76. Please also note that we did not use any reduction formula for trigonometry. Please make sure that you are not multiplying both sides by any number. You are just taking right-hand side to the left and solving the resulting equation by graphing it and finding its x-intercepts. The second technique is solving inequalities with TI 8384. While solving an inequality of the form f of x is greater than g of x, you will perform the following steps. Step 1. Write the inequality in the form f of x minus g of x is greater than 0, or f of x minus g of x is greater than or equal to 0, depending on how the inequality was given in the first place. Step 2. Sketch the graph of y equals f of x minus g of x. Step 3. Find the x-intercepts using the calculate 0, calculate minimum, or calculate maximum of the graphing calculator. Step 4. Observe the x values that make y positive. This will be the solution set. If the original inequality were given, like f of x is less than g of x, or f of x is less than or equal to g of x, then you would observe the x values that make y negative. For f of x is greater than or equal to g of x, or f of x is less than or equal to g of x, the solution set also includes the x-intercepts. Please note that if the inequality is trigonometric, then you should be careful to set the angle mode to degrees or radians depending on the mode of operation in the original inequality. You may also need to adjust the window settings, which means x-min, x-max, and x-scale, depending on the interval where x values are designated to be in the original inequality.